Congruence and orientation from a motion rule, okay? We're going to review what transformation is displayed above. It is a reflection, okay? So is the image congruent to the pre-image? Is it congruent to the pre-image? Yes, it is congruent. Has the orientation of the figure changed? Yes. So look at, if I read from A, right? I'm going to go from A to B. So it'll be A, B, and then from B to C, right? But if I come over here, I need to start on the same letter and the same orientation, which would be A, but now I'm going to C prime and then to B prime. So these letters are not reading on in the same order, right? And so the orientation has been lost, right? But the congruent part is still there. So yes, it is congruent. No, it does not preserve orientation. And remember that this transformation is a reflection. Okay. What would be the motion rule of this for this reflection? Well, remember that when you guys reflect something, the point of reflection remains the same. The one that's going to change is the other coordinate. So in this case, X is going to change, right? So you would say that X and Y original will transform to the opposite of X and Y, right? Based on the motion rule of for a reflection, congruency is preserved, but orientation is not preserved. What type of transformation is displayed above? Okay, it would be a translation, okay? It's a translation. Is the image congruent to the pre-image? Yes, it is congruent, right? Because it's the same shape, the same size and the same shape. Has the orientation of the figure changed? Well, let's find out. C prime to A prime, right? And A prime to B prime. Now let's read on the original. C, I'm going to start with C again. So C to A and A to B. It is the same orientation. The letters are in the same order. So therefore the orientation has been preserved, right? This is a translation. So point A is 3, -1, and point A is -3, 1. What is the motion rule for this translation? So remember that translation has to be X plus or minus something and Y plus or minus something. That's going to be your translation rule. So look at, always go to the original, always go to the original point. If the original point is at 3, -1, right? And we moved it, because that's what you do in translations, you just slide things around, right? It goes to -3, 1. Well, how many spaces did it go up or down? How many spaces did it go left or right? Look at A, blue, which is the original, and then look at A prime, which is the new one. What happened to those points? It went up how many spaces? How many spaces did it go up? And you're gonna move up and left. So you're going to go negative on the X, positive on the Y, because you're going up. So up means positive, left means negative, right? So you're going up 2, and then you're going to the left 1, 2, 3, 4, 5, and 6. That would be your motion rule. Okay. Based on the motion rule for a translation, congruence and orientation are preserved. What transformation is displayed? This is a rotation. Is the image congruent to the pre-image? Yes, it is. This is a rotation. Okay. And is the image congruent? Yes. Is the same shape and the same size. Okay. Has the orientation of the figure changed? No. Okay. It has not changed because if I read A to B, B to C, so I say A, B, C, right? And if I come over here, even though it has been rotated, if I start reading at A, yes, to the right, it would be B prime and then C prime. Okay, so it has not changed the orientation. The orientation has been preserved. What is the motion rule for this 180 rotation? If you notice, whether it's counterclockwise or clockwise, 180 degrees has the same rule, which would be X and Y has been transformed to opposite of X and opposite of Y, okay? Based on the motion rule for the rotation, congruence is preserved, but orientation is not preserved. Okay, so we're going to review dilations. This is a dilation, right? Remember, we just talked about dilation and congruency and orientation. So orientation has not changed, right? So orientation is kept. However, congruent, it is not, okay? Because the new shape is way bigger than the original. So congruency has been lost and orientation has been kept. If I read C to A prime to B prime, right? And then I read C to A original to B original. So the letters go in the same order from reading from left to right. So what is the motion rule for this dilation? The way you find the motion rule for dilations is image over pre-image. I'm going to pick a point. I'm going to stick with the positive. So if I get 1 and 4 for A, right, I'm going to put it on the bottom. 1, 4. I'm going to get the image, which is 2 and 8. So if I divide these two, my scale factor is going to be 2 divided by 2 is 2, right? I'm sorry, 2 divided by 1 is 2. And 8 divided by 4 is also 2. So your rule would be 2 times the value of x and 2 times the value of y, okay? Based on the motion rule for the dilation, congruence is not preserved, but orientation is preserved. Remember that if I move C to A prime to B prime, as well as CA original, A to B original. So translation, it is congruent and it does preserve orientation. The rules are always adding, subtracting, okay, from X and Y's values. On reflection, reflection is the only one that does not preserve orientation, is still congruent, and you only have 2 rules for those for that transformation, which would be opposite of X, Y, and X opposite of Y. Okay. When you talk about rotations, there are a total of 8 rules because you have counterclockwise and clockwise, but technically there are only 4. It just depends which way you go to. And X and Y will be transformed to opposite of X, opposite of Y, which that would be 180 degrees. And opposite of Y, X, that could be a 90-degree counterclockwise, or it could be a 270 clockwise. It just depends which way they're telling you to go. Dilation. So dilation does not preserve congruence. However, orientation is kept, okay? And the rules for dilation would be anything that is multiplying with the scale factor that is multiplying with the X or the Y values. Right here on this chart, you can actually see the difference between translation and dilation, as we talked about it yesterday, right? Where translation only adds and subtracts, and dilation actually multiplies with the scale factor, which then becomes the coefficient of that x or that y.